Hi everyone, and welcome to the introduction to lesson 5.3, volumes by cylindrical shells. So we're given this formula in our lesson, and there are quite a few things to know about this formula. The first thing we're going to look at is the circumference. Okay, so circumference, the formula is 2 pi times the radius. So this x represents the radius. Now, if you're doing a horizontal rotation, a rotation around a vertical line, okay, we're going to use x values. Okay, that means that this is going to be an x, you're going to have an x in your function. But if we're doing a vertical rotation, we're going to use y values. So this x would change to a y, and you'd use y's in your function. Okay, so the radius, generally, if you're just going around an axis, is just going to be an x value or a y value. So you're just going to keep x or y there. Now, if your axis of rotation happens to be not an axis, so not the x-axis or y-axis. So let's say I'm rotating around -2, or here, maybe it would be -2. Okay, so if I'm doing a horizontal rotation around the -2 line, and notice my area is to the right of that, okay, I'm going to do x minus that axis of rotation value, so x minus -2. If I'm doing this vertical rotation, I'm going to do y minus that axis of rotation value. And that's because we want to have a positive radius. I need the distance from this -2 to my x value. So notice it's 2 units here and then an extra x units to there. Same thing here. It would be 2 units to here and then an extra x units up. That's why we do that. Now, if my axis of rotation is above my area, so maybe it's up here at 4, or if the axis of rotation is to the right of my area, over here at 4, what I would do is I'd switch the order. So I'm going to do 4 minus my x value, or 4 minus my y value. And that's, again, because I would need to have a positive radius value. I'm looking at the radius value from this 4 down to whatever y value I'm looking at here. So 4 is the highest it could go, and I have to subtract out that y value to get this distance, because this is the y down here. This is the y distance, and I do 4 minus that y to get this radius distance. Okay, that's basically everything about that circumference formula. Next, let's look at the height formula. Okay, the height is determined generally by the height of the function. So generally, that's going to be whatever function you're given. So like if this was like -x² minus 4 or something like that, I would just put the function right in there. Okay, same thing here. Whatever function this was, you would put it in, but for this one, you'd make sure it's in terms of y. So you'd put in things that have y variables in them. Okay, so that's generally what happens with height. However, if we have 2 functions, okay, we're going to be using subtraction to do our height. So when we do it, let's say this is g of x on the bottom and f of x right here. We need the height of this cylinder. So I'm going to do f of x minus g of x, the top one minus the bottom one. And that's going to get me the height. So if I have 2 functions, I have to do some subtraction. Now, if I'm rotating in the other direction, if I'm doing a rotation around this x-axis, okay, the height is determined in this direction. So I would end up doing g of x minus f of x to get this height. And I always sketch these graphs. And it doesn't have to be an accurate sketch. I just sketch it quickly, and I just make sure of what this height is before I actually put it into my formula. Now, the last thing we need to talk about in our formula is these limits of integration, the a and the b. Okay, again, if we're looking at a horizontal rotation, okay, they're going to be x values. The x values where it intersects the x-axis. Okay, if we're looking at a vertical rotation, they're going to be y values. where it intersects the y-axis. And if we have two functions involved and we're doing a horizontal rotation, you're taking the x values where those two functions cross. If we're doing a vertical rotation, we're taking the y values where the two functions cross. Okay, that's basically everything about this formula. Now, the question is, when would we want to use this? Our other formulas were working well. Well, a lot of times we use it when we have one function that's going to determine an outer radius and an inner radius. So this function is going to determine the two radii. So one function determining the two radii, we're not going to be able to use our washer method on that. However, we can use this method for any rotation where we're looking for volumes. It works anytime, and sometimes it's actually easier than the disc and washer method. Okay, so that's it for this video. Come back again for another example video.